Yes. Next, we'll see definition. What is regular expression? Okay, the regular expressions over an alphabet summation are all and only the strings that can be obtained according to the following rules. Okay, here you see null is a regular expression. I told you no, the regular expression is a combination of the symbolic representation of the regular language. Okay, regular expression is a symbolic representation of the regular languages. We are going to use some letters. Okay, the letters are going to combine with some symbols. Okay, we are going to combine the letters or alphabets by using the sum of the symbols. Okay, the obtained expression we are going to call it as a regular expression. We have seen no regular language. L is the regular language. Okay, in that W is a string. Okay, set of strings having AAB as a substring. W is a string having AAB as a substring. Okay, it is an English like statement. Okay, the same thing we are going to write in the form of expression, mathematical expression. In that we are going to use some of the symbols. Okay, we'll see what are those symbols. Okay, here you see the first thing is what here, null is a regular expression. Okay, if you want to see a null language, okay, it is going to be represented by this symbol. Okay, if you want to express null language, language itself is not there. Null means language itself is not there. If you want to show that, okay, symbolically we are going to use this one. This is a representation of the null. Okay, if you want to represent regular language, okay, with a empty string, a language is having the empty string. Okay, if a language is having empty string, how symbolically we are going to represent? By using the symbol epsilon. By using the symbol epsilon, epsilon represents null string. Okay, this null represents what here? Null language itself, and the epsilon represents null string. The language is having the null string. The language is having null string. Okay, after that, every element of summation is a regular expression. Okay, what are the whatever the elements are there in the summation, no alphabet set. Okay, individually all are going to be called as a regular expressions. Every element of this summation set or alphabet set, okay, individually we are calling them as a regular expression. Suppose you imagine that summation is equal to a comma b comma c and close. Alphabet set is having the A, B, C. Now A, B, C individually we are calling them as a regular expressions. Okay, regular expressions. Okay, some operations you see here. Okay, if alpha and beta are regular expressions. Okay, if alpha and beta are regular expressions, then alpha dot beta, dot is not there here. Okay, I told you in yesterday class, dot you may use alpha dot beta, or directly you can write alpha beta without any gap. Okay, directly you can write alpha beta continuously, or you can use dot in between them. Alpha dot beta is equivalent to alpha beta. Okay, if alpha beta are regular expressions, then alpha beta is also a regular expression. The meaning is that the concatenation of alpha with beta is also a regular expression. Okay, is also a regular expression. Next one, if alpha beta are regular expressions, then alpha union of beta, okay, is also a regular expression. Alpha union of beta meaning is that here alpha or beta. Alpha or beta, the meaning of this is what here? Alpha or beta, alpha union beta. If alpha and beta are regular expressions, then alpha or beta is also a regular expression. Just wait. This is very important for to solve the examples. Okay, you see here in this concept. Okay, especially on the attack, there are fixed questions are there here. Okay, the same only you are getting. The same means same type of examples only you are getting in the first model. First, he may ask some of the definitions and applications of the automata, string, alphabet, concatenation, okay, replication, okay. He may ask some of the basic definitions, along with you have to give the some of the examples, and he may ask what you mean by regular language, what is regular expression, yes or no. He may ask that type of questions. After that, directly he may ask you to design the DFSM for the given language, design the NDFSM or NFA. NFA or NDFSM both are same here. Okay, NFA means non-finite automata, and DFA means deterministic finite automata. Okay, here DFA means deterministic finite automata, NFA means non-deterministic finite automata. Okay, both are same here. NFA or DFA or DFSM or NDFSM. Okay, he may ask you the question that, okay, design the DFSM or NDFSM for given language, or epsilon NDFSM or epsilon NFA, and minimization of DFSM or DFA. Okay, these are the possible questions from the first model. Okay, in the second model also there are some questions are there here. Okay, you will get the same type of questions in the external examinations. Okay, for to solve those questions you should know all these basic things. Okay, for to solve those questions, okay, you should know all these basic things here. Okay, here is alpha beta regular expressions, then alpha concatenating with beta is also a regular expression. Okay, if alpha beta are regular expressions, then alpha union of beta is also a regular expression. Alpha or beta or alpha union of beta. Okay, if alpha is a regular expression, then so alpha raised to star, alpha raised to star is also a regular expression. Okay, the meaning of this alpha raised to star is, okay, it may have zero or many number of alphas. Okay, alpha raised to star meaning is that it may have null or any number of times of alpha value. Okay, zero or any number of times. Okay, next one, if alpha is a regular expression, then alpha raised to plus, alpha raised to plus meaning is that, okay, at least it should have one time alpha. Okay, at least one time alpha or many times alpha. Okay, alpha raised to plus meaning is that here at least one time alpha or many times alpha. Okay, alpha raised to star meaning is that here null or many times alpha. Okay, null or any times alpha. It may have 0 also, 1 also, 2 also, 3 also, and any number of times alpha. That is meaning is alpha raised to star. Okay, and with respect to alpha raised to plus, okay, it should contain at least one time alpha. So that alpha, 2 times alpha, 1 time alpha, 3 times alpha, 4 times alpha, any number of times of alpha is okay with alpha raised to plus here. Then if alpha is a regular expression, then you can write in the parenthesis. This is also a regular expressions. You can write directly or you can write in the parenthesis. Both are same here. Okay, both are same. Okay, some more basic information. What is regular expression? Okay, a method to describe a regular language. Yes or no? You can represent. Okay, you can represent finite state automata by using the regular language or regular expression. Both are okay here. Okay, you can construct the FSM by using the regular language also, by using the regular expression also. Both are same here. So regular expression is a method to describe regular language. Okay, a regular expression is a method to describe a regular language. Okay, we are going to describe the regular language with some expression. Okay, we are going to define the regular language with some mathematical expressions. Okay, that is going to be called as a regular expression. Both are same only. We are going to define something with a English like statement, that is going to be called as a regular language. Okay, we are going to define something with a mathematical expression, then that is going to be called as a regular expression. English like statement here, here mathematical statement here, both are same. The meaning of both will be same here, but this is a English like statement, but this is a mathematical statement. How? We'll see in the further slides. Okay, and you see here, this regular expression consists of two kinds of symbols. Okay, I told you, no, we are going to represent with the help of the mathematical expression that is going to have the some of the symbols, symbolic representations. Okay, it consists of two kinds of symbols. Okay, special symbols. Okay, set of special symbols to which we will attach meanings when they occur in the regular expressions. Meaning is, we are going to use some of the special symbols in the expression, in the regular expression. What are the symbols? Okay, I told, no, null. Null means what? Null language, empty string, epsilon, union, and parenthesis, opening parenthesis and closing parenthesis, star. Star means null or any length of character. Null or any length of character. Here, plus means one time or any number of times character. Yes, sir, here 0, 1, 2, 3, any number of times an alphabet may appear. Here, it should appear one time, at least one time, or it may appear any number of times. That is a plus meaning. Okay, all these are the some of the special symbols we are going to use in the regular expressions. Okay, all these are some of the special symbols we are going to use in the regular expressions. Next one is alphabet, that is summation. Yes or no? These are the some of the special symbols. Okay, after that we are going to use alphabet. Okay, alphabet means it is having the sum of the strings, no? Yes, sum of the input values. Okay, all by using this sum, by using the alphabet. Okay, by using the alphabet letters and by using these symbols, we are going to write the mathematical expression that is going to be called as a regular expression. Okay, that is going to be called as a regular expression. Okay, by using the alphabet and by using these special symbols, we are going to write the regular expression. Okay, here you see some examples. You see here regular expression examples. Okay, if summation is equal to a and b. Okay, if summation is equal to a comma b, the following are the regular expressions. The following are the regular expressions. Okay, here you see null. Null is the regular expression. Okay, and epsilon. Epsilon is the null string itself. Okay, a may be the regular expression. The individual characters also regular expression. A and B also. Okay, and A union B raised to star also regular expression. Okay, and A B B A union of epsilon is also a regular expression. Okay, and B star A union of B B raised to star after B is also a regular expression. Okay, all these are the regular expressions from the given summation. Okay, all these are the sum of the possible regular expressions. It may be null also, it may be epsilon also, it may be A also, it may be B also, it may be A union B star also, or anything. Okay, okay, anything from the alphabet set with a special symbols. Okay, anything from the alphabet set A and B and with a combination of special symbol also, that is going to be called as a regular expression. Okay, all these you can see, all are the possible regular expressions from this A and B. Still many are there. Okay, still many are there. I have written some of them here. Okay, let us see with more examples. Then only you will have a clear idea. These are some of the things here. Just to observe here. Define L. L is the regular language. Okay, the interpretation function for regular expressions are L of null is equal to null only. The language with null, the language with empty is equal to null itself. Okay, the language with empty string is a epsilon only. Okay, the language with having C. Okay, C is an character from the alphabet set where C belongs to summation. This C. Okay, just to observe all these things, let us see the examples on all those things. Okay, L of null will be null only, L of epsilon will be epsilon only, L of C is equal to C. The C means it is an alphabet from the alphabet set summation. Here you see that is concatenation, that is union, which are same as in the previous slides. L of alpha into beta, I can have L alpha dot L alpha beta, concatenation of alpha with beta, concatenation of alpha, sorry, union of alpha and beta. Just to observe these things. Okay, no need to worry about the how it is L here. L is a regular language here. Okay. Okay, all these things we have discussed in the last thing. You just observe what is plus. Plus means 0 or any number of occurrence of the particular symbol. Star means 0 or any number of times occurrence of the particular symbol. Okay, just to observe this one. Plus meaning is that here the symbol should appear at least one time or it may appear many times. Okay, plus raised to plus meaning is that here at least it should appear one time or it may appear many times. Star meaning is what here? It may appear 0 times also, it may appear a number of times also. You just see the difference between star and plus. Okay. Yes. Here you see some of the basic regular expressions. Okay. How to write the regular expressions from the regular languages. Okay. In these examples, we are going to see how to write the regular expressions from the regular languages. Okay, how to see the regular expressions from the regular languages. Okay. Yes, you see here some basic regular expressions. Okay, this is what here? L is equal to epsilon. L is the language, it is having empty string. Okay, L is the language, it is having empty string. The corresponding regular expression will be RE, that is regular expression is equal to epsilon 1. If the language is having null string, then the respective regular expression will be epsilon itself. Epsilon itself. Second, you see, L is the language. Okay, L is the language of a set of string W over an alphabet A star. W is equal to A. Now, the string W is equal to A. It is having only A. Okay, so that the possible strings are A only. The possible strings are A. Yes or no? W is equal to A. Only A it should appear. Only A. The FSM is going to accept. W is equal to A is there. Only string A is going to accept by the FSM finite state machine, so that the possible strings will be L is equal to A. L is equal to A, so that the regular expression is also A. The regular expression is also A here. Third one you see here, L is equal to a set of strings W over an alphabet A star. W is equal to optional A. The definition of the language is W is equal to optional A. Optional means what here? It may there or it may not there. It may there or it may not there. Okay. It may not there means what here? So that the possible strings will be, the possible input strings for the machine will be epsilon, no, optional means what here? It may there or it may not there. So that epsilon means what here? Null string. And a means it may there or it may not there. It may there for this a is there, it may not there for this epsilon will be there. So that the possible strings for this language will be epsilon and a, epsilon and a. Okay, so that this one we are going to represent with a regular expression like this. Okay, regular expression is equal to epsilon union of a. Okay, the regular expression, this is what here, this is the regular language. We already discussed all these things in the first module. Okay, the same thing we are going to represent in the regular expression. Regular expression is just like a mathematical expression. It is having the sum of the characters along with the sum of the special symbols. Okay, here you see uh, epsilon union a, epsilon or a, epsilon or a. It may there or it may not there. We are going to represent like this, epsilon or a. Fourth example you see here, L is equal to, L is a language of set of strings W over an alphabet A star. Okay, the string, okay, is what here? W is equal to AA. W is equal to AA. The meaning of this one is what here? The FSM is accepting only AA string. The finite state machine is accepting only string AA. So that the possible strings for the language will be AA only. Yes or no? Here W is equal to AA is there. So that the possible strings for the language to be accepted is only AA. So that the regular expression for this given language will be AA only. Yes. Next one you see here, fifth one. L is the language of set of strings W over an alphabet A star. Okay, and W is equal to A comma AA. W is equal to A comma AA. Meaning is that here it should accept A and AA only. The machine should accept A alphabet and AA alphabet, so that the possible strings for the language are, the possible strings of the language are A comma AA. Okay, these two only are going to be accepted by the FSM. So that the regular expression for this language is A or AA, A union AA. So that this is representing that here the machine will accepting A or AA, A or AA. Yes. Next uh, example is sixth one. You see here the regular language he has given here. L is a regular language of a set of strings W over an alphabet A star. Okay, the condition for this language is W is equal to even number of A's. Okay, already we have discussed the same example in the first module. Okay, W is equal to even number of A's. Okay, W is equal to even number of A's. Okay, even means what here? Only it should contain the A's. Even, however, only A is there in the summations in the alphabet set. Only letter A is there. Okay, the condition for the language is even number of A's. Even number of A's means what here? Zero occurrence of A's, 2 times, 4 times, 6 times, and so on. Only even number of times it is going to be appearing. Okay, so that the possible strings for this language are epsilon. Epsilon means what here? Zero, no, null string. Epsilon meaning is null string, 2 times, 4 times, 6 times, 8 times, and so on. Okay, these are the possible input strings for the FSM. Okay, this is the regular language. This is the regular language. Okay, these are the possible input strings for the FSM. Okay, for this one we need to write the regular expression symbolically. Okay, you see here I have written like this: regular expression is equal to AA whole raised to star, AA whole raised to star. Okay, I told you that the star meaning is that here, what is star meaning? Zero or any number of times occurrence of the particular character. Star meaning is what here? 0 or any number of times appearance of the particular character. Here you see, I have written 2 times A. Okay, I have written 2 times A in the bracket. Okay, after I have made a whole raised to star. If star is 0, if star is 0, then whole will be 0, no, null. It will be null. If star is 0, 0 occurrence, so that it is epsilon. If star is 1, okay, this raised to 1 will be AA, 2 times A. If star is 2, 2 means 4 times A, 1 time 2 times A, okay, and if it is 3, 6 times will be. If it is 4, 8 times will be. Okay, you see here, if star is 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on. What is star meaning is a 0 occurrence or any number of times occurrence of the special character. Here I have written AA. Okay, so that this is the regular expression for the given language. You can observe here, it is going to satisfy the condition of the regular language. 2 times A I have written, 2 times A raised to 0 means 0 only. Okay, and 2 times A raised to 1 is 2 times A, 2 times A raised to 2 is 4 times A, 2 times A raised to 3 is 6 times A, so that for all the occurrence, okay, it will be even only, it will be even only, so that this will be the regular expression for this regular language. Okay, next you see here, uh, L is the language, okay, which is defined over an string W, okay, with a set of strings A, okay. W is equal to odd number of A's. The condition for the given language is W is equal to odd number of A's, okay. Odd number of A's means what here? Okay, these are all the possible strings. Yes or no? These are all the possible strings for the given condition of the language. Odd means 1 time A, 3 times A, 5 times A, 7 times A, 9 times A, and so on it will be. Yes or no? So that how it will be the regular expression? How it will be the regular expression? Okay, you see, this is the regular expression for the given language. This is the regular expression for the given language. You see here, I have written symbol A here. I have written letter A. Here A is the, I have written 1 time A here. I have written 1 time A. Okay, I am going to concatenate this A with 2 times A raised to star. Okay, I am going to concatenate this single A with 2 times A raised to star. Okay, this single A is compulsory. This single A is compulsory in the expression, and this one you see, the meaning of this one is what here? 0 occurrence of A's, 2 times occurrence of A's, 4 times occurrence of A's, and 5 times occurrence, 6 times occurrence of A's. The meaning of this one is what here? Even time occurrence of A's. You see, the previous example is there, no? The meaning of this one will be even times occurrence of A's. Okay, so that I have attached one more A here. One more A here, so that even time plus one more A will be always odd only. Okay, even times of A's. Okay, even times of A's attaching with one more A, so that always it will be odd only. Always it will be odd. Yes or no? If star is 0, this whole will be 0, 1 time A. Correct? If star will be 1, 2 A plus 1, 3 A is odd. Okay. If star is 2, okay, 2 into 2 is 4, 4 A plus 1 A is 5 A. Again it is odd. So that for each and every value of this star, the resultant value of this whole expression will be odd only. So that this whole will be the regular expression for this given language. Regular expression for this given language. Okay. Next example you see here, 8th one. If L is the language which is defined over an string W, okay, or A and B star, okay. W is a set of strings over an alphabet A comma B star, okay. The conditions for this one is A comma B, okay. The strings which are accepting by the machines are A and B. The strings which are accepting by the machines are A and B. So that the possible strings for this one will be A comma B. So that the regular expression will be A or B, A union B. Yes or no? A union B. Okay. Yes. Next example you see here. W is a set of strings over an alphabet A comma B star. Okay, the length of W is even. The length of W is even. Yes or no? The length of W is even. Okay, only I am going to concentrate on the length only, irrespective of the what are the what will be the letters. Okay, here you see the possible things are epsilon. Epsilon meaning is 0. Okay, 0 is also a even. 0, 2 time 2, 2, only length, whatever it may be letters. Here two A's are there, AB is there, okay, BA may be there, whatever it may be. Only I am going to count the number of letters. Okay, 2 times, 2 times, 2 times. Okay, 0 times, 2 times, 4 times, 6 times, 8 times, and so on. Whatever may be the combination of the letters. Okay, all are going to satisfy the condition of the given language. Here, the length of the W is given irrespective of whatever may be the letters in this. Okay. Okay, how to construct the expression? How to construct the regular expression? Hmm. Okay, here you see. Okay, you carefully observe here. A or B, A or B concatenating with one more A and B whole raised to star. A or B concatenating with A or B whole raised to star. Okay, this is going to satisfy the given condition of the language here. Okay, here you see, it may A also, it may A or B. Here also you see, suppose I am going to have A here. Suppose I am going to have epsilon also. Here star is there, no? Star meaning is it may have 0. 0 means epsilon is there. Okay, or any number of times of the possible letters here. Okay, here A or B. From this parenthesis, okay, I may have A or B. From this parenthesis, I may have A or B. Okay, so that here from this parenthesis, I will have 1. From this parenthesis, I will have 1, 1, 1, 2. Okay, 2 raised to star is the value of star will be 0. No, if it is 0, epsilon. If it is 1, 2 times. If it is 2, 4 times. If it is 3, 6 times. If it is 4, 8 times. Or any combinations of A and B. Okay, don't worry the combinations of letters. Only I am going to concentrate on the number of letters. Here I may have A. Here also I may have A. Here also I may have B. Here I may have A. Any possible combinations of A and B, but the count will be 2 here. But from this one I will have 1. From this one I will have 1, 1, 1, 2, 2 raised to star. Star may be 0, 1, 2, 3, and so on. Okay, the same I can write like this also. The same, this one is there, no, the same I can write like this also. You can compare. You see here, there is no fixed thing is there here. Okay, you can construct the FSM or regular expression on your own way. Okay, there is no fixed design is not there here. Okay, that is depending upon the intelligence of the people, how they are going to design. You see here, I told you in the previous first module, minimization of DFA or DFSM. Okay, some people may construct the DFSM with the help of 6 states. Some people may reduce the number of states. Okay, they are going to construct the same thing with the 4 states. Both FSMs are going to satisfy the condition of the language, but one FSM is having 6 states, one is having 4 states. So that is depending upon the person, how he is going to design. Here also, this is equivalent to this one. Here you see, AA, union, yes or no? Here star is there means what? A zero or a number of times of occurrence of the values here. AA union, AB union, BA union, BB. Okay, union is there. I may have this one, I may have this one, I may have this one, I may have this one with any possible, with any number of times. I may have AA with any number of times. I may have AB with any number of times. I may have BA with any number of times. I may have BB with any number of times. Even I may have 0 also. Okay, both are equivalent with each other. Both are equivalent with each other. And next example you see here the same, this is a even, this is a for odd here. Yes, I am going to end up with this session in 5 minutes. Just I am going to complete this 10th example. Okay, L is equal to W is a set of strings over an alphabet A and B star. Length of W is odd. The length of W is odd means what here? I may have all possible combinations. One time A, one time B, A, B, B, A, B, B, any possible combinations. One time, 3 times, 5 times, 7 times, with any possible combinations of A and B here. With any possible combinations of A and B. Okay, you see here already we have got this with an example of E1. Okay, already I am having this one for the E1, so that the same I will write here. The same I have written here. This is for E1. A or B, one A or B, A or B, I will have one letter from this one. A or B, I will have one letter from this one. 1 is 2. 2 raised to star means what here? 0, 1. This will be always 1 with any possible combinations of A and B. Okay, along with I have concatenated with A or B. Along this one, I have concatenated with A or B, so that this is always E1. I am concatenate A or B. From this one, I will have one letter. It may be A or B. So there 2 plus 1 is 3. It is odd. If I am having 4, 4 plus 1, 5. Yes or no? After the 6 plus 1, 7. So that if for this one, it is odd. For this one, it is odd. Okay? The same I can write like this also. In this previous example, it is there, no? The same I can write like this also. This is for one time. This is for one time A or B. Yes or no? One time, one letter will be there. From this one letter will be there. Either it is A or B. Yes or no? From this one, I will have 2 letters. Any combinations of A and B. 2 letters plus 1 letter, 3. Star is there. Star means 0, 1, 2, 3. It will be there. Okay. For star, it will be 0, 2, 4, 6, 8 like that. Okay. For all these things, I am going to attach A or B, so that always the whole will be odd only. So that this is the regular expression for this given language. Okay. In the tomorrow class, we will see some more examples. Okay. All these are all very important for solving the examples. Okay. Tomorrow I am going to continue with the remaining the examples. For any doubts, put a message in the chat box, or directly you can call me and rectify your doubts. Yes. Yes, I am going to end up with the today's session. I will continue in the next session. Thank you. All you can do the meeting. Thank you.